All right, so scientists, some, are sounding the alarm on a so-called solar superstorm that could, and this is important, underline the word could, eventually wipe out the internet for weeks or even months.
Scientists have revealed that a new solar storm is coming, and it may have dire consequences for the world. Reports suggest that this storm will be the biggest humanity has seen in 100 years, and may have the power to take down Earth's entire technological infrastructure. So, what is the cause of this imminent wave of disruption? How will it impact humanity, and do we need to be worried? Let's take a closer look. The imminent solar storm. Indian astronomers have recently issued a cautionary alert, expressing concerns about an impending powerful solar storm that has the potential to disrupt global internet connectivity for several weeks. Researchers have made a noteworthy discovery regarding the correlation between the sun's magnetic field and its sunspot cycle, offering insights into predicting the peak of solar activity.
The sun has a very predictable, but actually quite mysterious cycle of activity. It gets very, very active every 11 years, and then it settles back down to more of a peaceful existence.
Initially, NASA projected that the next solar maximum would commence in late 2025. However, a recent study has disclosed an accelerated timeline, suggesting an earlier onset, most likely in early 2024. The study, led by physicist Dibyendu Nandi from the ISER Kolkata Center of Excellence in Space Sciences in India, forecasts a solar event in early 2024. While predicting the exact intensity and repercussions of these solar storms remains challenging at this stage, Nandi emphasizes that further understanding will unfold as the new year approaches. On a positive note, he acknowledges the aesthetic aspect of solar storms, mentioning the creation of beautiful auroras. Thus, there is optimism that 2024 may be a favorable year for aurora hunters. However, some scientists are sounding an alarm, interpreting the rapid increase in sunspots as a potential precursor.
When you start seeing more and more sunspots, there's an expectation that you're going to see more intense and more frequent solar flare.
To a significant event akin to the historic Carrington event. The sun, a colossal sphere of hot, electrically charged gas, perpetually undergoes dynamic movement, giving rise to a formidable magnetic field. This magnetic field experiences a cyclic transformation known as the solar cycle, recurring approximately every 11 years. A noteworthy event within this cycle is the complete reversal of the sun's magnetic poles, signifying a switch between the north and south poles. The solar cycle significantly influences surface activity on the sun, notably the formation of sunspots, attributed to the sun's magnetic fields. Monitoring the solar cycle involves tallying the number of sunspots. Initiated by a period of solar minimum, characterized by the least occurrence of sunspots, the cycle progresses as solar activity and sunspot numbers steadily increase. The midpoint, termed the solar maximum, marks the phase with the highest sunspot count. Subsequently, the cycle wanes, returning to the solar minimum before initiating a new cycle. Examining historical data, such as sunspot counts during solar maximum phases in 2001, compared to weaker phases in 1996 or 2006, reveals the cyclical nature of solar activity. Nearly a century ago, Swiss astronomer Max Waldmeier made groundbreaking observations that continue to guide contemporary scientists in predicting solar maximums. In 1935, Waldmeier discerned a compelling pattern associated with sunspot cycles, a correlation between the rapid ascent of a cycle and its eventual strength. He noted that stronger cycles exhibited a faster journey to maximum strength. Termed the Waldmeier effect, this revelation functions as a predictive tool for scientists, akin to a crystal ball. By scrutinizing the early stages of a sunspot cycle, researchers can estimate its eventual strength. Employing this methodology, NASA scientists have foreseen that the forthcoming solar maximum is anticipated in the year 2025. The new discovery. Contrary to previous expectations, Indian astronomers have unveiled that the impending solar maximum is approaching earlier than anticipated, likely manifesting in early 2024. The breakthrough in their prediction methodology involves establishing a novel relationship using decades-old data archives from various ground-based solar observatories worldwide. Dr. Nandi and his team's research delved into the correlation between the rate of decrease in the sun's dipole magnetic field and the rate of ascent of the ongoing sunspot cycle. During the solar cycle minimum, characterized by a scarcity of sunspots, the dipole field strength reaches its maximum. As the sunspot cycle commences its ascent, the large-scale solar dipole field weakens, assuming a more intricate configuration. Eventually, it vanishes at the sunspot cycle peak, undergoes a directional flip, and gradually begins to regenerate. Applying this innovative approach, Indian astronomers have determined that the anticipated solar maximum is likely to occur not in 2025, as previously projected, but rather in the early months of 2024. The ramifications of this solar maximum are expected to be profound, with potential disruptions to the global internet for several weeks due to exceptionally potent solar flares. Moreover, prior predictions by researchers emphasize the significant challenges Earth's communication systems may face during the upcoming solar maximum. The most intense solar storms possess the capacity to induce catastrophic orbital decay in low Earth orbiting satellites, posing a threat to satellite-based services, including communications and navigational networks. But how strong will this event really be? Has something like this happened before? In August of 1859, a remarkable celestial event unfolded in the skies, captivating astronomers globally. Richard Carrington, an avid skywatcher residing in a small town near London, became an unwitting witness to an extraordinary spectacle of the sun. Engaged in sketching sunspots on September 1st, Carrington was momentarily blinded by an intense flash, initially attributing it to potential damage to his observation equipment. Rushing outside, he discovered that the bright spots on the sun's surface had vanished. Unbeknownst to him, what he had just observed was a colossal eruption known as a coronal mass ejection. Ordinarily, it takes days for a coronal mass ejection to traverse the vast expanse between the sun and Earth. However, this particular event defied expectations, making the journey in a mere 17.5 hours. While Earth's magnetic field typically shields us from such solar storms, the 1859 incident was exceptional. A geomagnetic storm ensued, manifesting as mesmerizing auroras in the sky. Yet beneath the celestial beauty, a disruptive force unfolded. The impact of the 1859 solar storm was astonishing, releasing energy equivalent to 10 billion megatons of TNT from the sun. This event, famously known as the Carrington event, had far-reaching consequences. Electrical systems across Europe and North America faltered, revealing the vulnerability of technological infrastructure to such natural phenomena. In the contemporary context, scientists issue a sobering warning. If a similar event were to occur today, it could lead to an internet apocalypse. Extreme voltages unleashed by a violent solar storm could wreak havoc on electrical grids, potentially causing damage to undersea cables that power a significant portion of the world's internet. In recent online discussions, growing concerns have emerged regarding the potential recurrence of a solar event akin to the Carrington event, particularly as we approach a peak period of solar activity projected for 2024. Anxiety looms over the possibility of such an occurrence in the upcoming new year, prompting worries about its potential impact on our highly interconnected world. The Royal Observatory in Belgium has contributed to these concerns by reporting that the number of sunspots has reached the highest level in the past 21 years. Throughout June, an average of 163 sunspots per day were recorded. This data indicates that the current solar cycle has exhibited more activity than initially predicted by NASA, with the official forecast projecting around 115 sunspots at the peak. The unexpected increase in solar activity has left scientists puzzled, prompting the need for further study to comprehend the internal processes of the sun. While solar cycle number the 25th of May not be the most robust in history, scientists anticipate it to be one of the most potent solar cycles we have encountered. Despite lacking precedents for extreme events, there is uncertainty about how our infrastructure would respond to such an occurrence. The need for comprehensive research and understanding of these solar events is crucial, considering the potential implications for our technological and interconnected systems. What do you think? Should we be worried about this solar storm, or is our infrastructure strong enough to withstand it? Please share your thoughts in the comments below.